Section 2, Systems Development Lifecycle. It's a challenge to develop and deliver software. Developers need to quickly build secure solutions that are reliable and can scale to meet customer demands. Operational stability and rapid feature development are two goals that might seem like they're far apart, and methodologies are needed to bridge the gap between them. The Systems Development Lifecycle, also known as the SDLC, helps to bridge the gap between the stability of an organization's operations and the need for rapid feature development. The SDLC is a model that's used to describe the stages in software development. These stages include the initial feasibility study all the way through the deployment and ongoing maintenance of an application. In general, the steps in an SDLC methodology are plan, define, design, develop, deploy, and maintain. This course will primarily focus on the develop phase, but will also touch briefly on the deploy phase. During the develop phase, developers and engineers acquire and install new system components and applications. System users are trained, and all aspects of the new system are tested for performance. If needed, bugs are fixed and adjustments are made to improve performance. Two of the most common SDLC methodologies are waterfall and agile. The waterfall, or traditional methodology, uses sequential development phases, which have distinct tasks and goals. Work is passed to the next phase only after all tasks are completed in the current phase. Waterfall projects often have long periods of time between when the software is first planned and when it's deployed. This also means the customer doesn't have an opportunity to provide input until after the software is completed. The Agile methodology is a framework that uses an iterative development process. Each iteration is referred to as a sprint, and each sprint includes the different phases, from planning through maintenance of a software product. Sprints average 1 to 4 weeks long. Each iteration builds on the last until the completed product is deployed. Because sprints usually have short durations, customers can provide input and direction as the product develops. This also means that requirements can change, and these changes can be incorporated into the application's development. The major phases of software development are develop, deploy, and maintain. The develop phase can be further divided into the code, build, and test phases. During the code phase, developers write the application source code and use a source code repository, such as a Git repository or an AWS code commit repository for version control. Teams might use code reviews or pair programming to provide feedback on code quality. In the build phase, developers compile the source code and verify the quality of the code by using different tests. One type of test is a unit test. A unit test is written in code and helps to ensure that the application logic meets requirements. Tools used here include style checkers and code metrics utilities. Other tests include integration tests, load tests, user interface tests, and penetration tests. Integration testing checks how well the code works for other systems. For example, the connection to the database server is tested. During load testing, utilities simulate user traffic on the application. Load tests are critical because they help ensure an application will perform as expected if it has a large number of users. In user interface tests, or UI tests, users test how the application works. The selected testers open the application for the first time and use it. UI tests help developers know whether the application is easy to use and functions as expected. Finally, during penetration testing, the security team checks whether the application infrastructure is resilient to attacks from outside the organization. The purpose is to simulate situations where malicious, unauthorized users attempt to take over the application resources. The next main phase is deploy. During this phase, the application is deployed to production. Different deployment strategies exist, but the common goals are to reduce risk when new changes are deployed and minimize the impact if a bad change is released into production. Finally, the application enters the maintain phase. During this phase, end users use the application regularly. Operations teams ensure the application runs as expected, and security teams monitor the system for any signs of a problem. Thanks for watching, and see you in the next video.
Welcome to Section 3, Steps to Get Started Developing on AWS. Before you start developing on AWS, you need to create an AWS account. After you set up your account, create a user in AWS Identity and Access Management, or IAM, and assign permissions to that user to be able to access specific services and operations. Next, install your development environment for the language of choice. This step includes installing AWS SDKs for the language of choice, such as the AWS SDK for Python, which is called Boto 3. You might also install the AWS command line interface, or AWS CLI, so that you can interact with AWS services. After you set up your access and your environment, you can finally start interacting with AWS services. To create an AWS account, start at the AWS homepage. Then choose Create an AWS account. Note, your steps might vary slightly if you've already signed in to AWS. Enter the requested information and choose Continue. You'll be asked if the account is personal or professional. Because you're using this account for learning purposes, select Personal, but both types have the same features. Next, enter your personal or company information. If you're creating a professional account, enter your company information, such as your organizational email address. Note, if you use your personal information to set up a professional account, you might make the account less secure. For either type of account, confirm that you're able to access the email address you entered. The system will send a confirmation email message to the email address, and you'll need to verify the account before you can use AWS services. Next, read the AWS customer agreement and agree to it. Finally, choose Create Account and Continue. So, you've created your AWS account and you're logged in. Great. When you first sign into your account, you're signing in with the account root user. This user has unlimited access and permissions, so it's a best practice to only use the root user when it's required. Instead, create another user that you'll use only for development. Use the AWS Identity and Access Management Service, or IAM, to create this account. With IAM, you can specify who can access resources, what resources they can access, and how they can access these resources. Here's an example of how to use IAM. When you use IAM to create a user, the account is called an IAM user account. In this example, a user account is created for John. Next, John is added to an IAM group. Groups are a convenient way to organize users and associate permissions to the entire group. Here, the members of the developer group have the permission they need to develop on AWS. The permissions are applied to the entire group, so all users who are members of the group are granted these permissions. This means that updates to the permissions will affect all group members. This method of assigning permissions is more efficient and less error-prone than manually applying permissions to each individual developer. An IAM role is an identity with specific permissions that users assume. After a user assumes a role, they are granted the permissions associated with that role, and only that role. In the example, because John is a member of the developer group, he has the permissions needed to assume the developer role. Finally, apply a policy statement to the role. Policy statements define permissions for users and resources. You'll learn more about IAM in the next module. Next, you need to install and configure a development environment before you can begin to code. Many IDEs support developing on AWS, and some offer additional features that work with AWS. Examples of IDEs include Eclipse IDE, Microsoft Visual Studio, PyCharm, and Rider. By default, most IDEs don't automatically include functionality for AWS. However, you might be able to install AWS extensions after you install the IDE on the development computer. Next, you'll learn about the AWS Cloud9 IDE. Thanks for watching. We'll see you in the next video. One specific IDE of interest is AWS Cloud9. It's a hosted service in AWS that offers all the features of a modern IDE. Because it's available as a web application, you can access the environment from any device with a web browser. You can share an AWS Cloud9 environment with other developers for both individual work and real-time team coding. AWS Cloud9 supports many languages such as Python, PHP, JavaScript, and C++. Another feature of AWS Cloud 9 is that it works with other AWS services, such as AWS Lambda, which is a serverless runtime environment. For example, you can use AWS Cloud 9 to navigate through the Lambda functions available in the region where the AWS Cloud 9 instance is deployed. You can then import the code into AWS Cloud 9 and use Cloud 9 to make updates to the code and push it back to Lambda. When you create an AWS Cloud 9 environment instance, you attach to it by using a browser on your local computer. During setup, the AWS Cloud 9 instance can be associated with a pre-existing development server or with a new compute instance in Amazon Elastic Compute Cloud or Amazon EC2. The server where your AWS Cloud 9 instance runs is referred to as the environment where you'll develop code. Like all modern IDEs, AWS Cloud 9 can connect to code repositories. For example, AWS Cloud 9 integrates with AWS Code Commit, which is a fully managed Git-based source control service hosted in AWS. The AWS Cloud 9 IDE has a fully featured editor. It can handle large files that contain 100,000 or more lines of code. It offers multiple themes and customizable run configurations. The editor also offers Vim and Emacs modes. AWS Cloud 9 also supports shortcuts and keyboard navigations commands, such as the ones in Vim. And as another benefit, AWS Cloud 9 environments include a pre-configured installation of the AWS Command Line Interface, or AWS CLI. As you write code inside the AWS Cloud 9 environment, you can choose from many different available run configurations. The slide shows the full list, which includes C++, Java, Python, Ruby, and TypeScript. If you need a configuration that isn't available, you can create a custom run configuration with the New Runner option. When you create a new runner, you select the program needed to run the code, such as GCC for C++. You can also add the other configuration parameters you need to run code. AWS Cloud 9 can store multiple custom run configurations, which are formatted in JavaScript, object notation, or JSON. Another feature of AWS Cloud 9 is that it integrates with Amazon Code Whisperer. Amazon Code Whisperer is an artificial intelligence, or AI, coding companion that generates code suggestions based on comments and existing code within AWS Cloud 9 and other supported integrated development environments, or IDEs. It provides real-time support for code authoring directly in your IDE. By automating repetitive and common coding tasks, it optimizes the use of developer time so developers can focus on more critical aspects of the project. Code Whisperer uses generative AI to give code recommendations based on natural language comments, the code that's been written, and existing source code. Along with AWS Cloud 9, Code Whisperer integrates with several other IDEs and programming languages. For more information about other IDEs and languages that Code Whisperer is compatible with, see Amazon Code Whisperer in the Content Resources page of your course. Amazon Code Whisperer is trained on billions of lines of code, and it's best used for undifferentiated, repetitive common coding tasks. Some of the benefits of using Amazon Code Whisperer are: it helps developers accelerate any coding task by generating code suggestions in real time. It can suggest anything from code snippets to complete functions. Developers can get code suggestions that are optimized for AWS APIs, including Amazon Elastic Compute Cloud, or Amazon EC2, AWS Lambda, and Amazon Simple Storage Service, or Amazon S3. Code Whisperer helps developers use AI responsibly to avoid bias by filtering out code suggestions that might be considered biased and unfair. Additionally, Code Whisperer also has a security scanner that helps mitigate security vulnerabilities, safeguarding the integrity of the code base. When scanning for security vulnerabilities, Code Whisperer assesses your code against multiple sets of standards and best practices. These include the following: Open Worldwide Application Security Project, or OWASP, Crypto Library Best Practices, and AWS Security Standards. It generates entire functions and logical blocks of code, often consisting of up to 10 to 15 lines of code, directly in the IDE code editor. Code Whisperer accelerates the implementation of unit tests. Not only can it implement the logic for most of the explicit unit tests, but it often suggests unit tests for edge cases. For more information about Amazon Code Whisperer, see Amazon Code Whisperer in the Content Resources page of your course. Amazon Code Whisperer uses natural language processing of comments in the code to anticipate how a developer is going to finish a line of code or a comment line. It can generate a full function, or it can complete a code block. It can suggest functions to complete doc strings, and it can provide line-by-line suggestions as a developer codes at their own pace. Code Whisperer generates code similar to how the developer would write code, matching their style and naming conventions. The developer can quickly accept the top suggestions with the tab key, view more suggestions with the arrow keys, or continue writing their own code. There are 2 tiers of service for Amazon Code Whisperer. The Code Whisperer individual tier is available to use at no additional cost. Individual developers can sign up and sign in using an AWS Builder ID. You need an email address to obtain an AWS Builder ID. The individual tier provides code suggestions, reference tracking, and security scans. The Code Whisperer Professional tier is available for a flat subscription fee to professionals that have an AWS account. In addition to the capabilities offered in the individual tier, the Code Whisperer Professional tier offers administrative capabilities to organizations that want to provide their developers with access to Code Whisperer. Administrators get organizational license management to centrally manage which developers in an organization should have access to Code Whisperer. They also get organizational policy management to set service policies at the organizational level, such as whether developers are allowed to receive code suggestions that might be similar to particular open source training data. For more information about how to set up Amazon Code Whisperer, see Setting Up Amazon Code Whisperer in the Content Resources page of your course. Thanks for watching. We'll see you in the next video. Welcome back. You can interact with AWS through the AWS Management Console, or you can interact with AWS programmatically. With programmatic access, services can be called through the AWS CLI, the AWS SDK for the supported language, or the Service Application Programming Interface, or API. Regardless of the interface you use to access AWS resources, the calls pass through an API. You can interact with the APIs to access your AWS resources in 4 ways. The first is by calling the APIs directly. The second, by using the AWS Management Console. The third is using the AWS CLI. And finally, the fourth is using the AWS SDKs. In the example on the slide, service access passes through an API, whether you configure and start EC2 instances, upload files to an Amazon S3 bucket, or update an item in an Amazon DynamoDB database. If you want to call the AWS APIs from the command line, several tools are available. The first tool is the AWS CLI. It runs on Microsoft Windows, Mac OS, Linux, and Unix. You can also run the AWS CLI in Docker containers. Windows PowerShell users can use the AWS tools for PowerShell. It's built with the AWS SDK for .NET, and it provides Windows users with the ability to interact with AWS resources from the PowerShell command line. Another tool is AWS Serverless Application Model Local, also known as AWS SAM Local. This is an AWS CLI tool to develop serverless applications locally. It provides an environment that runs on your local computer to build, test, and debug applications that will run on AWS. When your application is ready, AWS SAM can also deploy it to AWS. For mobile app development, you can use AWS Amplify. Amplify helps automate the creation, configuration, and implementation of scalable backends for mobile apps. It's a framework that integrates backend services with mobile frontends, such as iOS, Android, web, and React Native. We'll now talk about using the AWS CLI to run commands. Calls made from the AWS CLI contain a few basic elements. A command always begins with AWS. This string is how you invoke the AWS CLI. The next part of the command is the service. In this example, the command is EC2, which calls the Amazon EC2 service. Other examples would be using S3 to work with Amazon S3, or using Route 53 to work with Amazon Route 53. The third part is the operation, or subcommand. This is a service-specific command. In the example, the first command uses the stop instances operation. Calling this operation on an EC2 instance will cause the server to shut down. Finally, the call includes any parameters the command needs to run. The first example specifies the instance ID of an EC2 instance as the target of the stop instances command. Sometimes you need to specify several parameters when you run CLI commands. The commands themselves can be complex, so if you need to run a complex command, you can use a configuration file. This file stores the parameters, which you specify with a CLI input JSON parameter. The second example shows this by using a configuration file called webserver.json. The lower part of the slide shows that you can use the help command when you need assistance with the CLI. In the first example, running AWS help will display general help for using the CLI. Running AWS EC2 help will display information about using the CLI with Amazon EC2. When the final example is run, it will show information about running the describe instances parameter with the EC2 operation. AWS Cloud Shell is a web-based command line interface, and the AWS CLI is pre-installed on it. You can access Cloud Shell through the console, and it automatically authenticates your sessions by using the credentials you use to log into the console. You don't need to use the authentication keys that you would normally need to use the CLI. In addition to the AWS CLI, Cloud Shell also includes the AWS SDKs and other tools to help you work with AWS resources from the CLI. The latest versions of the tools are installed, so you don't need to install updates or patches when you use Cloud Shell for the first time. Cloud Shell incurs no cost and comes with 1 GB of persistent storage per region. You only pay for the resources you create and run on AWS. Because the storage is persistent, you can store scripts, files, and utilities. And you can access these resources in your Cloud Shell environment across the region. Thanks for watching. We'll see you in the next video.
Welcome to Section 4, Part 1, Fundamentals of Working with AWS SDKs. The AWS SDKs support many different languages. Whether you're using C++ to write back-end code, JavaScript to build your application front-end, or Python to work on big data, AWS offers an SDK to support your project. AWS also offers mobile SDKs to support languages such as Swift, which runs on iOS. For example, if you're using an Internet of Things or IoT device, such as a Raspberry Pi or Arduino, you can find AWS SDKs for supported languages on those platforms. When using the AWS SDKs, it's important to understand the request-response model that's used to call AWS service endpoints. Say that you have an application, and it uses an AWS SDK. In the request-response model, your application initiates a request by using either the service client or resource APIs. We'll talk about those resources soon. When the application makes the request, the call is sent to the API that supports that service. After the service completes the work from the request, it returns a response object. Your application code consumes the response object, which contains information such as the results of a database query, output from a Lambda function, or the contents of an S3 bucket. Note the callout at the bottom of the diagram. The endpoint that your code calls is a URL. As long as your device has access to the internet, your application should be able to connect to the desired AWS service endpoint. In addition, the response codes that the service endpoint returns follow the standards for the HTTP response code series, such as 200, 400, and 500 series codes. Now we'll use code examples to look at what Service Client API and Resource API mean. The AWS SDKs have 2 levels of APIs. The first is the Service Client API, which represents the low-level client in the SDK. Using a low-level client gives you more control over the requests that you make to the service, which provides the ability to more closely control the behavior and performance of your calls to AWS services. In this code example, the list client function is written to access an S3 bucket called doc_example_bucket. First, the client is instantiated by the client operation from the SDK for Python library. Next, the client calls the list objects v2 operation on the bucket itself. This line sends a request object to the Amazon S3 service endpoint. If the bucket doesn't exist, it returns an error. The code then iterates over the bucket's contents. For each object that's found, the terminal prints its name and its last modified attribute. Now we'll look at the same functionality, but by using the Resource API. Resource APIs provide an object-oriented interface to AWS resources. Resource APIs provide a higher level abstraction than the low-level calls that service clients make. In the list resource function, first, an S3 resource object is instantiated by using the resource operation from the SDK for Python library. This resource object is then associated with the doc example bucket S3 bucket. From there, the name of the S3 object and its last modified attribute are printed. Thanks for watching. We'll see you in the next video. Section 4, Part 2, Fundamentals of Working with AWS SDKs. In the previous samples, you saw code that interacts with Amazon S3. Bucket names are unique across AWS partitions, so it isn't necessary to specify an AWS region for an S3 bucket. However, some services have resources that are associated with a specific region. In these cases, you must specify a region. The slide shows a code example that specifies a region. The code is going to access DynamoDB, so it specifies where the table is located. The region name parameter indicates that the table is located in US East 1 region, which corresponds to the US East region in Northern Virginia. When the AWS SDKs determine what region to use, they follow what's called the default region provider chain. Here's an example. When you run code in Java, the SDK first looks for the region as it's specified in the code. This is what you see in the top example on the slide. Then, the SDK looks for the value of the AWS region environment variable. Next, the SDK looks for the value in the ~.aws/config file. This is shown in the bottom example on the slide. In the example, the region is set to US West 2, which corresponds to the US West region in Oregon. Next, if the code is running on an EC2 instance, the code uses the instance's metadata to determine what region the instance is currently running in. If the Java SDK cannot determine the region through these steps, client creation will fail. Other languages and their associated SDKs follow a similar chain to determine regions. Be sure to consult the SDK documentation to understand the specific region chain for the language you're using. Unfortunately, errors happen. When they do, error handling is key to elegantly handling the condition. The AWS service endpoints return error messages, which the AWS SDKs parse. In this example, a request was made for a JPEG image that doesn't exist. You can use the information in the error message to create a method to handle the condition. The HTTP response status codes can be useful when you need to decide how to handle various errors and conditions. With 400 series errors, the problem occurred on the client side. In this case, you, as the developer, need to handle the error. With 500 series errors, the problem occurred on the service side. When this happens, retry the operation. The AWS SDKs assist with 500 series errors by using an exponential back-off algorithm to retry the operations. Usually, retrying the operation results in success, and the program can continue. Each language supported by an AWS SDK has classes or functions to help you handle exceptions. Java, .NET, and Xamarin have the Amazon Service Exception and Amazon Client Exception classes. Python code can use the botocore.exceptions.client error class to handle exceptions. The SDK for JavaScript includes an asynchronous callback that contains error data. Regardless of where the error happens, whether it's in the client or is the result of a back-end exception, it's the developer's responsibility to handle the problem. An end user shouldn't know that an error occurred. Thanks for watching. We'll see you again in the next video.
Now it's time to review the module. In summary, in this module, you learned how to recognize the systems development lifecycle, describe how to get started developing on AWS, identify the benefits of using the AWS Cloud9 IDE, identify the benefits of using Amazon Code Whisperer with AWS Cloud9, develop and run a simple program in AWS Cloud9, and indicate